So this lesson is an extension from yesterday's lesson on quadratics and using them to model real world problems. And we are trying to find when something is going to hit the ground. We are going to do this with no calculator because for the math one, this is going to be on the no calculator part of the test. Yesterday in the calculator, we just used our table to find when the height was 0, and we could find when it hit the ground. But today we're going to do the exact same thing. We're just going to do it without a calculator. So here we go. Number 1, that function represents the approximate height of an object x seconds after it is launched. How many seconds does it take for the object to hit the ground? Well, h of x represents the height. Well, if it's hitting the ground, what is my height? My height is 0. So I take my function and I set it equal to 0. Now all I have to do is solve this. Okay, so this is quadratic, so we're going to factor it. We talked about how when there's a negative in the front, you're always going to take a negative out, and it looks like I can take a 2 out. So we're going to GCF a negative 2, so that would be x squared plus 3x minus, okay, and now I need to do 2 into 56 without a calculator. So 2 into 5 goes 2 times, that'd be 4, and 2 into 16 is 8. So 28. And if you can do that in your head, fantastic. If not, that's how you work it out without a calculator. Okay. Then I've got a nice little trinomial. I want the factors of 28 that subtract to give me 3, and that would be 7 and 4. Signs are different. Bigger number gets the positive. Then I take these and set them equal to 0. That one has no x's in it, so not interested. So these are my 2 x's. Well, x represents seconds. Well, I can't have negative seconds, so this answer does not make sense. The answer is 4. Now here's why you're getting 2 answers. Remember, this is quadratic, so his graph is a parabola. It's negative, so it opens down, and your y-intercept is 56. So way up here at 56, your parabola is doing this. So yeah, he's going to cross here and here. This is just when you start to throw something and it's going to hit the ground. So I'm interested in that one. This is just the other half of the parabola. I'm not interested in that one. I always want the positive answer. So the answer here is 4 seconds. So the function h of t equals negative 16t squared plus 32t plus 48 represents the approximate height of a cannon ball in t seconds after it's launched. How many seconds does it take for the object to hit the ground? Okay, again, hits the ground. I want it equal to 0 because the height is 0. I'm going to take a negative out, and then with a 16, a 32, and a 48, I can take a 16 out. So that would be t squared minus 2t minus 3. And I've got a nice little trinomial. Factors of 3 that subtract to give you 2 are 3 and 1. Signs are different. Bigger number's negative. Set all your pieces equal to 0. So I have 2 answers. I know I don't want the negative one. So it will take 3 seconds for it to hit the ground. A punter can kick a football from the ground with an initial velocity of 48 feet per second. How many seconds will it take for the ball to return to the ground? Okay, well on this one they didn't give us a function, but we remember so that's my velocity and that's my starting height. My velocity is 48 feet per second. My starting height is 0 because it starts on the ground. So I'm not going to put the plus zeros. So here's my function, and I want to know when will it return to the ground. So I'm going to set it equal to 0. Okay, I'm going to GCF a negative 16 and a t. I only have two terms here, and they both have a t. T minus 3. I don't mark this one out. I have to actually solve it because it has a t. So here are my two answers. So here we go. We've got a cannon that's being shot from here to here. So this one is when it starts, and this one is when it drops. So I want this one. I want 3 seconds. Okay, that function represents the height of a rock t seconds after it's thrown from a riverbank into the Dan River. How many seconds until the rock hits the water? So its height is going to be 0. So I'm going to take the function. Set it equal to 0. I'm going to GCF a negative 16. No t this time because this term doesn't have a t. Let's see, 16 times 6. Yep. Minus 6. Factors of 6 subtract to give me 1 are 3 and 2. Signs are different. Bigger numbers negative. Now I set all of these equal to 0. That one has no t's in it. This one I'm going to add 3. And this one I'm going to subtract 2 and get a negative answer. And I don't want a negative answer because it's talking about time. Okay, the function f of x equals and represents the height of a pumpkin launched from a catapult x seconds after it's launched. How many seconds will the pumpkin hit the ground? So I'm going to take my function, set them equal to 0 because I want them to hit the ground. This is a GCF. I can take a negative, a 6, and an x. X minus 2. Take both of these, set them equal to 0. Add 2. So this is when it starts. I don't want that one. I want to know when it lands. So that would be 2 seconds. Okay, represents the average motion of a kangaroo in seconds as it's jumping across the Australian desert. On average, how long is a kangaroo airborne on each jump? So I want to know how much time passes between each jump. So let's see, I can take a negative, a 10, and an x. So x squared minus 4, and then those are squares. So x and x, 2 and 2, 1 plus 1 minus. And I have 3 parts that I set all equal to 0. This one has an x, so we have to solve him. Okay, so here we go. I have 3 solutions. All right, now think about this on a graph. That means I have a point there, and there, and there. So here's your kangaroo bouncing. So it wants to know how much is in between each bounce. 2 seconds. Don't want the negative, don't want the 0. I want the positive 2 seconds. Okay, that function represents the height of a golf ball after it's hit. After how many seconds will the golf ball hit the ground? Okay, so I'm going to set them equal to 0 because it's hitting the ground. Take a -3 and an x. So x squared minus 9. These are squares. Then set them all equal to 0. This one has an x, so we have to solve it. That one's going to give me a -3, and that one's going to give me a +3. I don't want the negative, I don't want the 0. 3 seconds. Golf ball's in the air. Okay. Number 8. That function represents the trajectory in seconds of a ball as it rolls off of the roof of a house. After how long will the ball hit the ground? Okay, well, hits the ground means set it equal to 0. Okay, they don't have anything in common, but remember we said if there's a negative in the front, you have to take it out. So I'm going to take a -1 out. I can't take an x because he doesn't have an x. But I am going to divide everybody by -1. So that's x squared plus 4x minus 5. Factors of 5 that subtract to give me 4, 5 and 1. Signs are different, bigger numbers positive. Then set all of these equal to 0. He has no x's. That one's going to give me a -5, and that's going to give me a +1. And I want the positive answer. So +1. So to find when something's going to hit the ground, take its function, set it equal to 0, factor it, and solve it. On your factoring, remember you can GCF, you can do a trinomial, and you can do squares. Just remember all the factoring that you've learned, and you should be fine.